Tēnā koutou katoa no Aotearoa o Tamaki Makoro ahau, ko Raafey tako ingoa, tēnā koutou, tēnā koutou, tēnā koutou katoa. Thank you all for coming to my talk. So yeah, let's pick our AppSec toolkit. Oh, yes, all right. Yeah, big thank you to the sponsors before we get things off. Wouldn't be here without all the money that they've given to make this event happen. So who am I? I'm Raafey. I am an application security consultant at Datacom. Basically, that means for about, since I started my career, I've been generally trying to convince people that security is a good idea. More recently, after moving into more specified field of application security, I've been convincing them that securing their applications during the development process is a good idea. Obviously, you're all here at this conference about security, so we're not going to go too much into that. We'll talk a little bit more about how we make that happen. Generally, I focus a lot on the automated security testing side of things. That's what we're going to be talking about today. We do some training, which I was running a couple of courses over the last couple of days. Some of you happen to attend. I also do a lot of governance, cyber risk management, all of that sort of good stuff. So why am I here today? AppSec testing tools are really evolving. They're changing how they work, how good they are, how effective they are. A year ago, when we were at this OWASP Day conference, there wasn't any AppSec tooling vendors that were sponsors. This year we have 4. So I think we're seeing a bit of a change in the market, and hopefully that means a lot more sort of pickup in New Zealand organizations utilizing these tools as well. We have tested and used a whole lot of them. So I want to share some of the things that I found that I think are cool, are interesting, are not so cool, so hopefully, and then help you decide which ones you should probably look at, what things you should look out for. Important thing to note is they are evolving, they're getting better, but no tool is perfect at the moment. They all have their quirks that people should look out for. So we're going to talk through all of this. So I have been doing this sort of stuff for a little while now as part of getting this ready and kind of getting our recommendation criteria ready for how we present these tools to various clients and help them select them. First of all, we used a whole lot of external research, the reports from Gartner, Forrester, the stories that a bunch of our people in our team had to tell about their struggles with some of these types of tools. We defined a fairly big requirements matrix. I'm going to talk more about this a little bit later. And then we used these tools to scan Datacom-built applications and basically evaluate them against this big list of things that we thought that they should all be doing and doing quite well. So today, I'm going to be sharing some of the more interesting findings from the study that we've been doing for about 3-4 months now, just looking at these various tools. It's not kind of everything we did. Maybe I'll do an extended talk, maybe a couple of hours if I get the opportunity somewhere, talk through all of the different things that we looked at and how these tools performed in those areas. Before we get into the more interesting stuff around what we found, what I think is working well, what's not working well, a little bit about what is an AppSec testing tool. I've said this word already about 4 or 5 different times. So for the purposes of this presentation, it's any tool that's designed to analyze and test applications for security vulnerabilities. They come in lots of different flavors. I'm going to quickly rattle through a whole bunch of them. There's a whole lot more beyond this as well. So for the code you write, we have static analysis or SAST. For the code you don't write, so these are all of your third-party libraries and your libraries dependencies and their dependencies and 15 layers deep, what vulnerabilities exist on those. For the infrastructure templates that you use, so IAC is common. People also call it policy as code. So things like Terraform, ARM files, scanning those for misconfigurations. For the container images you use, so we have container scanning, or some people call it base image scanning. People have lots of different names for things, so I'm trying to kind of cover a broad range here. And then when the application is being tested, so when you're running your unit test, you can use things like IAST, interactive application security testing. When the application is running, you can use DAST, which is dynamic application security testing. And then now finally, maybe you've done all of these things and we've finally got the application into production. WAF, Web Application Firewalls, not traditionally considered security testing tools, but they do tell you, they analyze your application, tell you what vulnerabilities are there. Real-time application self-protection are similar, but that sits in your application, whereas the WAF sits in front of it. And then we have all of the runtime infrastructure scanners, so things like your Nessus, your Qualys, and a wide range of cloud security tools, all designed to figure out what vulnerabilities exist in your applications. So I'm going to run through some things that I think are interesting. The emojis are to represent how I feel about them. You'll get a bit of a hint around what's coming next based on the emoji. So the first one is AppSec testing tools are changing rapidly. So I first started looking at these types of tools about 3 years ago when on a project we said we need a SaaS tool. At that time, I didn't really know what that meant. So we went to a guy, he said, use this, and we did. So looking at kind of the categories across the top, about 3 years ago, the real focus was just on static analysis. That was what application security testing tooling was. Everyone did third-party library dependency testing, but that wasn't really advertised as much. It was kind of stuck onto the end of it. Then we had, the dynamic and interactive, which some vendors did, some didn't. And then the container and the IAC wasn't really something that we were scanning when we were building our applications. The infrastructure was, once it's in production, we'll run some scans on it and we'll make sure it's okay. But now, as we know, developers' jobs have changed a little bit. They're now also expected to look after the infrastructure as well as the code, as well as the build pipeline, as well as everything else. So now we need more tools to be able to help them do that because it's not easy to figure out everything that's going on. Nowadays, all of the red is to highlight the changes made in the last few years. There is a lot more focus on that right-hand side, that container and that IAC. The tools which traditionally started with the third-party library analysis or doing dynamic have kind of realized, actually, everyone wants SaaS as a starting point, so we need those as well. So this is a very rough overview of what's happened in the last few years, just based on the types of tooling they have. A lot more has changed as well. There's, all of these companies are making acquisitions like crazy. What that means is, one, all of these tools are getting better, but also all of my favorite open source tools from 2 to 3 years ago, you've got to pay for them now. Or you've got to use the version from 3 years ago, which isn't as good. Number 2, so this is one that is, pretty interesting to me. So software composition analysis tools, we talked about, we look at third-party libraries that we're pulling in. The big issue there is generally not the direct dependencies, so the things that are listed out in your manifest file, but all of the things that they're calling and, that big binary tree of 10,000 things that your Node application that, might only be a one-page app actually depends on. So, that makes me feel like this. So, this is my criteria for what a useful SCA tool should do. We've got a bunch of the tools across the top. I'm not going into the names of them at the moment. So first is provides a full manifest of all third-party components that your application is actually using. So new regulation in the US, if you're selling applications or software to the federal government, it needs to have a software bill of materials. Your tool, you need to know everything that's going into it. A lot of these tools are focused on security, just where the holes are. So they're not providing you that full list. To me, it's quite important that it kind of just shows you this is everything in our app. So now tells you which versions of the components you're using. Surprisingly, one of these tools doesn't do that. I thought this would be kind of, really important when you're trying to figure out what's going on. Tells you which components are direct and which ones are transitive. So the next one is, really important here. So if we don't know which of these components is direct and which one is transitive, when you tell me to update Lodash from version 2 to version 2.1, but I don't know what is calling Lodash, that information to me is not that useful. What I want to know is what is the top level component and what version can I upgrade that to that now calls all of the upgraded versions of the transitive dependencies downstream. So it identifies upgrade paths for direct dependencies, really easy. I'm calling this dependency in my manifest. It's out of date, I need to upgrade it. Now, identifies upgrade paths for transitive dependencies. These are the downstream ones. And only 2 of the tools that we actually tested easily tell you that, yes, you're calling Lodash all the way down in this dependency tree, and if you upgrade this top path, that will fix that vulnerability. Then we get into the more interesting new type of things. So patches there's this library out there. Someone's found a security hole in it. That team who's managing that library is no longer managing that library. So some of these vendors are now starting to provide their own patches to fix these things. And then the last one is, okay, don't even worry about fixing it. We'll just create an automatic pull request for you. We'll put it into your backlog. All you need to do is just approve it, and done, you're approved. So yeah, the 2 things here that, there's a lot on the slide, but what I want you to take away is make sure your tool tells you what is transitive and what is direct, because without that single piece of information, it's kind of not that useful. And then make sure that it's actually telling you the upgrade paths for the transitive dependencies, not just telling you to upgrade something that you actually have no control over and you can't do. Okay, so now we're going to talk about static analysis a little bit. So there's a trade-off between the number of false positives and false negatives for static analysis. It makes me feel like this, not great either. Try to use a different emoji for each slide. So we have 2 axes. We have the false positive rate and the true positive rate. Now, for the purposes of this presentation, I've kind of redefined what these terms mean. That's why they're in quotations, not a scientific study. This is what I think kind of works. So our true positive rate has been defined as the total number of useful findings identified by a tool. Useful based on what the developer thought about it. I kind of went to them, said, hey, do you think this finding is useful? They either said yes or no, not really. That looks like something that we don't need to worry about. Or yes, I don't know if it is actually a vulnerability, but this piece of information is useful to me and I will use it to go and do some investigation. So how many one tool found over how many all of the tools found. So that's our axes across the bottom. And then our false positive rate. So the total number of not useful findings found by a tool over how many of them were useful. So now we're looking at just one tool's finding. It found 10 things, 5 of them were good, 5 of them were bad. We're saying the false positive rate is about 50%. So this is what it ended up looking like. So that's where we're kind of getting that idea of as that true positive rate goes up, so does the false positive, true positive goes up, so does the false positive. There is, of course, one little outlier, B, out in the corner, which just didn't perform that well in our limited testing scope. We tested about 3 or 4 different applications across this whole wide array, had those discussions with the developers, tried to figure out what was useful and not. What you'll also notice is that the true positive rate is relatively low. Like, the best one was just about above 35%. So are we confident if we run one of these tools, we're going to find everything wrong with it? Based on the kind of work that we've been doing, probably not. But we will find some things. But as we'll see in the next couple of slides, there's more kind of asterisks next to those points as well. Now this one, different tools identify different vulnerabilities. This is, I don't know why this happens, and I need to still go deeper into why this is a thing. But, okay, so first we've got a broken or risky cryptographic algorithm. 5 out of the 6 tools we used found this in this particular instance. Great, one of them didn't. Don't know why. I still need to figure out why that particular tool didn't find it. Now, SQL injection. Everyone's known about this, since before I was born. These types of tools all say that, they will find flaws like SQL injection because everyone knows what that is. But only 4 out of the 6 of them found it. not the best. Now we're going into cross-site scripting. Again, these are relatively simple vulnerabilities that have been in the OWASP top 10 for a really long time. This one, this particular cross-site scripting was only found by one of the 6 tools. And the same one for directory traversal in another C# application, again, identified by one tool out of the 6. What does this tell us? Well, we can't be confident that if we just run one of these scanners, we're going to find everything going on and everything wrong. Next one now. So this is kind of a complicated one to me anyways. So the engineering effort required varies significantly between, one, the tool that you choose, so the AppSec testing tool you implement, and the technology stack you have. So it's kind of dependent on both of these things. Just makes me think. So how to not make your devs hate you? So based on the tool that you pick, you may have to modify the build process. So a bunch of these tools will make you turn on things like debugging, may make you insert additional sort of parameters into your standard build process. Things that you normally wouldn't do, and it may take your standard build time, increasing it by a little bit or a little bit here and there. You may also need to customize the scanning build step to specify which languages you're using, or remove the third-party dependencies, or to zip up the package. Now, all of this sort of stuff may not sound that complicated, and it's not if you've got 2 or 3 applications. Now, if you've got 300 applications, and you have to figure out even which languages all of them use, and then specify which language is being used in each pipeline so we can get better scan results, that suddenly turns into quite a lot of engineering time, particularly if you have a ton of legacy applications that no one has worked on in the last 10 years, but they're critical to your business and they need to continue to run. You may need to create a new nightly or a weekly or a monthly build because the scan takes 10 hours. 10 hours is a bit of an exaggeration. The longest scan time I've seen has been about 3 to 4 hours, but you can't stick that in, your regular build process because your devs will either, get rid of it, or they'll just stop talking to you as a security professional. Or if you're in the dev team, everyone else will stop talking to you because every time they try to do a build, you're saying, hey, let's do a security check. It's just going to take 4 hours. And then based on the CI/CD you have, the SCM you have, the ticketing system you have, there's a whole lot of pre-built kind of integration patterns there, but they're not there for everything. So if you're using, something way out there, like some dude built 10 years ago, and that's your CI/CD tool, you're going to have to do some custom scripting to make these tools work. Not all of them provide a command line interface, which I think is also a little bit weird, because CLIs are really easy to put into your pipeline. That language is read by all of the tools, but some of them don't provide that. Therefore, you have to figure out how the API works for that tool, start making those API calls, hopefully chuck that into a script, and get it to run. Doesn't mean it doesn't work. No, it works. It just takes longer to implement. And depending on who's doing it, you might start to annoy people, and they might get busy and start doing something else. So back to point 1. So we're moving towards feature parity now, I think, yeah, but there's more distinguishing features that are continuing to come out. And these are some of the cool things that I think you guys should, look at. So this gives me kind of that nerdy face, probably into this stuff too much. But so this is what we're seeing now. These are some of the things that are emerging, and some of the things that people just told me that they're working on, which I'm really looking forward to. So scanning via API directly into your code repository. In the olden days as in a few years ago, we could only scan either in the build pipeline or by zipping stuff up and sending it through. So now a bunch of these tools are saying, actually, we'll just use an API call, go directly to your code repository, scan it, and tell you what the results are. What this means is you can get a scan up and running in as little as 5 clicks or under a couple of minutes, and you've got these results. Awesome. Automated fixes via pull request. So we talked about this previously, definitely in the SCA space. A bunch of tools are just creating pull requests on your behalf. We need to upgrade Lodash from 0.1 to 0.2. You don't even worry about making the change. Here's a pull request, just approve it, run it through a unit test, it works. Faster scan speeds, we're getting there, things are improving. I think a few years ago, the fastest scan speed was a couple hours for a big application. Some of the tools are coming out, and now you can actually get a scan running in your regular pipeline because it only adds 4, 5, maybe 10 minutes to it. Now, there's definitely a much greater focus on the developer experience. A few years ago, these tools were built for security professionals to do audits, to tell the developers how bad their code was. Now they are built for the development teams to use so they can figure out what issues there are and get them to fix it on their own. Things that are coming through, all-in-one UI/scanning mechanisms. Everyone bought a bunch of different tools and is now squeezing them together into a single user interface, into a single scanning point, which is really nice and useful. Correlation engines between different scan types. So now what we're seeing is you run a DAS scan, you run a SCA scan, you might even run an ISC scan, and then based on the type of vulnerability it is, it's telling you if, okay, we found the SQL injection via our SAS scan, via the dynamic one, we actually also found it. That means there's a much higher likelihood that this is exploitable. We're also getting this in with IAC scans. So our SAS scan says there's an issue, and then there's a misconfiguration in our S3 bucket or somewhere in our EC2 instance, which makes this more likely to be exploitable, which is really cool. And then now, this is what I hear is coming down the road, automated fixes for source code issues. So we found a SQL injection. Here's the change you need to make. Here it is in a pull request. Just commit the change and you're done. I am very skeptical of this, but a couple of vendors saying it's coming and it's going to be great. So watch this space, I guess. All right, so I've talked a lot about things that are happening. So what can you actually take away with this? What can you do about this with this information? So number one, we talked about tools are changing. They're changing at quite a rapid pace. So pick the tools based on the features that are available today. Don't be sold on things that are coming in 6 months or a year's time. Run a POC. POC, proof of concept, is probably the best thing you can do before committing this money. Make sure the new shiny features that they're promoting are working as they should. Number 2, 3, and 4, these are all kind of grouped together, Not all SCA tools make things easy. There's a trade-off between false positive, false negatives, and different tools identify different issues. That's all, may have seemed like a bit of doom and gloom, but these tools are still useful. All of the tools we use found some security vulnerabilities, and if they were remediated, would improve the posture of our application. So rather than focusing on how many issues a tool is able to find, focus on how many issues your dev team is able to fix based on the results of that scan. Now, run that tool in your environment for a week and just hand it over to the devs. And at the end of them, ask them, how many changes did you make on the basis of these results? And if they said we made 0 changes, well, one, either the tool just isn't doing enough to guide them into what needs to happen, or they spent no time on it. But if you see them engaged, they're using the tool, and they're able to make changes on the back of those results, that tool is more useful to you than another tool which found you 10,000 things, and because the issues were so complex and difficult to understand, no one did anything about them. And then finally, engineering efforts varies broadly between the tools. First thing to do is define your requirements. Know what you actually want to do. That's what I talked about before, defining your requirements. We have built out this massive Excel spreadsheet with about 100 different tooling requirements that may or may not be of interest to you. But you can kind of go through and pick through, yes, we want this, we want this, we want this. don't care about that. Let's give it a lower priority. If you want this big, beautiful kind of spreadsheet, not really that beautiful, but yeah, happy to share that. Let me know if you want it. My contact will be at the end of this. Hopefully one day we'll put it on GitHub. We'll see. And then the final point that I'm going to make is just choose the tool that your end users actually like. It doesn't matter like which one you, like if it's the best tool in the world, if your dev team, and that's generally your end users, don't like it, they're not going to use it, well, it's kind of pointless putting that in there. So look to them to get their feedback during the POC process and select the tool that they say is the best for how they work and how they want to work. At the end of the day, all of these tools, they are all pretty decent. They all work in different ways. You can make them all work in your environment, but some are just going to have more friction than others. So just ask the guys that you expect to be running these scans and looking at these results, which one's their favorite, and more than likely you're going to get a much better result at the end of the day than picking what tool security thinks is the best or what tool someone else thinks is the best. That is me. Thank you for coming along. I'm going to be at the Datacom booth if you want to come have a chat with me. My email address is on here. I lurk around on the InfoSec Slack. I don't comment much on the posts, but I'm there, and send me a message if you ever have any questions or anything like that. Thank you.